What makes a nuclear power plant great is that it utilizes nuclear energy. A nuclear material the size of a walnut can release the equivalent of 2,000 liters of energy in about 12 barrels of diesel fuel. And there can be tens or even hundreds of thousands of cylindrical particles like this in a nuclear reactor in a nuclear power plant. They're usually made up of uranium or plutonium oxides, and then encapsulated in an extremely heat-resistant metal alloy. To make fuel rods, a number of fuel rods are packed into pressure tubes to form a nuclear fuel assembly, which is then placed in a metal tank. Then they're placed along with control rods and coolant in a reactor vessel made of heavy steel, and finally into the reactor building. When the reactor unit is activated, a neutron strikes the nuclear fuel. It triggers a nuclear fission reaction. In this process, the neutron is absorbed and destabilizes the nucleus of the nuclear fuel, causing it to split into 2 or more nuclear fragments. Nuclear fission produces a very large amount of energy, usually in the form of heat, and these fission fragments release neutrons. The neutrons released can then hit other nuclear fuel nuclei, triggering more fission reactions. This chain reaction continues in the nuclear reactor. At this point, coolant flows through the nuclear fuel assembly to absorb the heat. The coolant is the medium used to carry the heat released in the nuclear reactor. Common types of coolant include water, heavy water, helium. It transfers the heat to the power plant's steam generators. As it passes through the pipes in the steam generator, it comes into contact with water or water vapor circulating outside, heating it up and converting it to steam. And then the steam drives a steam engine. The steam engine then drives a generator that produces electricity. As complicated as it may seem, it's all about boiling water. It's just a different way of boiling water. So, do you have a question? Will it explode like a nuclear bomb? Don't worry. Nuclear bombs are made of highly pure and dense uranium and plutonium. So when fission occurs, it leads to an uncontrolled fission chain reaction. In a nuclear power plant, the uranium or plutonium is divided into rods, not compacted together. In addition, the reactor vessel has control rods, which are made of a special metal that absorbs neutrons. This controls the number of neutrons and maintains the stability of the nuclear reaction. Okay? Now do you get it?